Welcome to the fourth presentation in Unit 4 entitled What Do I Call You? The first thing we look at is we say forgive your enemies but never forget their names by JFK. And then if you look at this is an interesting graphic because it shows what different people call carbonated beverages. You see soda on the coasts, you see Coke in the south, and you see pop in the Midwest and North region. So, the learning goals for this presentation are that students be able to name a covalent compound given the chemical formula and write the chemical formula given the name. So what we already know is we know that atoms need to satisfy the octet rule, the idea that you need 8 valence electrons around something to make it satisfied. So in order to do that, nonmetals have to go about it a little bit differently. Because they both want electrons, those electrons must be shared in what we call covalent bonds. So what we learned in the lab is that covalent compounds are always neutral, so we don't have to account for the charge. Instead, we just kind of leave the charge alone. Because the electrons are shared, we know the number of atoms needs to be specified using a prefix, and that the most metallic, so the furthest one to the left, goes first. So, whenever you have this, you have the number of compounds. There are about 114 elements that are arranged in different compounds. It makes an estimated 30 million unique compounds, so they all need a unique name. It's an interesting name, the wizard. So the covalent prefixes. There is no charge in a covalent bond, so the compounds must be differentiated based on the number of atoms. So you have to somehow differentiate between C2H, I don't know, 4 and CH4. How are you going to differentiate between those two? And so how you're going to do that is you're going to use a prefix unit. And the number of atoms associated with each is related to the geometric shapes associated with these. So you see something like an octagon or a pentagon or a triangle. Those have different prefixes associated with them that we tend to use in chemistry as well. The prefix chart is this. Anytime you have a one atom, it is referred to as a mono. 2 is di, 3 is tri, like triangle. The one that's for 4 is a little bit different. It's tetra. A lot of times people try and call it all kinds of different things like rectangular, but tetra means 4. Then you have penta, like pentagon, hexa, like hexagon, hepta, like heptagon, and then octa, like octagon. And it goes on. There are things like nona and deca and dodeca and all kinds of things. But these are the 8 that we're going to focus on. So whenever you name a covalent compound, the first thing you need to do is identify the first element in the compound. So if there's a single atom, write the element only. So for example, if we have nitrogen, I would write nitrogen, but because there's more than one nitrogen, I need to use a prefix. So because of that, I would put di in front of it. So dinitrogen indicates N2. Whenever there's a carbon, like here, or an element by itself, you just refer to it as carbon. You do not refer to the first element as monocarbon or mono anything. You just put the element first. Now, a lot of times there's some confusion as far as which element goes first, and it is always the most metallic one, so the one that's furthest to the left. So if you were to look at the periodic table, you'd see carbon in group 14, and you'd see chlorine in group 17. So because of that, carbon is the most metallic of those. Same thing with nitrogen and oxygen. You actually see those right next to each other. You see nitrogen and oxygen. Nitrogen is to the left, so it goes first. The second thing you need to do is you need to name the second element. Now, regardless of what the second element is, there is always a prefix for the second element. In addition to that, you have to replace the ending with "ide." So no matter what, you see dinitrogen, and even though there's one oxygen, you still have to put a prefix on the second one. So it's dinitrogen monoxide. You see carbon, there are 4 carbons, so it's carbon tetrachloride. So it says, what should you have? What should you have a prefix for the first element in a covalent compound? The only time you should do it is the element if there are more than one. So for example, like C2, I would put dicarbon. Okay, if you have something like N3, it would be trinitrogen. Okay, so the only time that happens if there's more than one of the first one. Okay, you cannot have it if there's one. You would just put, you do not put monocarbon for the first one. So write the number of atoms for the prefix below. So for di, that means 2. Mono means 1. Hexa means 6. And octa means 8. says, what is the name of each covalent compound listed below? So the first thing we do is we name the element. So I would say nitrogen, because that's the first one. There's a 2, so I put a di in front of it. So dinitrogen, and then I have to put 3, tri, and then I replace the oxygen with oxide. Next, I look at this, 2, so I would put di-carbon, and then there's 6 chlorines, so I'd write it as hexachloride. The last one is sulfur. There's only one of them, but since it's the first element, I don't put mono. And the last one is 6 fluoride, so sulfur hexafluoride. So now, since a substance can have different names based on the presence of a single electron, what is the name of each of the substances below? Now this right here is from your polyatomic ions chart, and it is chlorate. This right here is not on your polyatomic ions chart, and instead needs to be referred to as, you'd have to rearrange it because oxygen is more metallic than chlorine. It'd be O3Cl. And at that point, you'd have something called trioxygen monochloride. So there's a very different answer based on the fact of this single negative charge. So now we need to figure out the chemical formulas, just like we did before. Chemical formulas are shortened versions of the name. They're really useful in chemical equations and useful as a shorthand so you don't have to write out the entire name. When you write the chemical formula, the first thing you need to do is identify the first element, and the first element you would write a symbol for. So in diphosphorus right here, phosphorus is the element, so because phosphorus is the element, I write a P. Then I look at the prefix, and I'd say, okay, the prefix says that there's a di, so I'd put a 2 there. So the 2 is a subscript, so it's a smaller number that's written just below the line, so you see P2. Now the next thing you have to do is you have to identify the prefix, okay, which we've already done. We've identified the prefix as P2. Next we need to repeat steps 1 and 2 for the second substance. So we have pentachloride. Whenever you have pentachloride, we say that it's chloride, and then penta means 5. How many atoms of nitrogen are there in tetranitrogen? So tetra is the prefix. Because of that, it would be N4. Next it says write the chemical formula for carbon monoxide. So the first thing you do is you look at the first element, you write a carbon. Now since carbon there's no prefix here and it's the first element, I know there's just one of them. I don't put a 1 right here because we leave it off. We just assume that it's a 1 unless it says otherwise. And then finally I see monoxide, and that's CO. And that's what you actually see right there. So it says what is the chemical formula for trinitrogen hexaiodide? So you look at trinitrogen, you'd say nitrogen is an N, tri means 3, iodide means I, hexa means 6, so N3I6. For pentaphosphorus octaoxide, you say, okay, I've got phosphorus, that's a P, penta means 5, oxide means O, octo means 8. And for the last one, you see carbon tetrachloride. Carbon is C. There's no prefix, so that's just a 1. Chloride is Cl. Tetra means 4. So CCl4. Finally, it says glucose and fructose have the same chemical formula. Why are there 2 names for the same substance? And the reason has to do with the way the atoms are connected. So even though something has an identical chemical formula, it can have a different name. So for example, I could connect the 6 carbons like this, where they all branch together, and then everything branches off of that. I could connect them in a ring, where they all connect together. I think I got enough carbons there. Now I'm 1 short. So if I'm 1 short, put another one in here. I could draw a ring structure. So sometimes, even though things have identical chemical formulas, does not mean they're the exact same compound.